Rainfall, the total amount of rain received on a given or during a given time as measured by a rain gauge. The water equivalent of all forms of atmospheric precipitation received in rain gauge. Result of condensation. Size of water droplets increase. They cannot remain suspended in the air. Factors influencing the amount of rainfall: latitude, temperature, moisture, air masses, frontal activity, differential heating, mountain barriers, distribution of land and water. Types of rainfall. Three types based on the process by which clouds are formed: conventional rainfall, orographic rainfall, cyclonic or frontal rainfall.
The first type of rainfall is convectional rainfall. It is a surface air heated up and rises up, cools down in higher altitude, falls down as rain, accompanies with thunder and lightning. Resultant clouds are cumulonimbus type. This is the process how convectional rain is created. First, the sun heats the land and air above. Warm air rises, cools, and condenses, forming clouds. Rain can then occur. Convectional rainfall. Rainfall is of short duration and heavy showers. Afternoon rainfall is the equatorial region. Occurs in early summer in the temperature regions.
Convectional rainfall. Water molecules on the Earth's surface continuously heat up and rises above. This is called convection. Once the water molecules reach a certain height in the atmosphere, the cold temperature, they start cooling them down, because of which they clump together and form clouds. The clouds then get heavier and heavier and finally fall down the water molecules back to the Earth's surface as rain. This rainfall is quite simply called convectional rainfall. Now, this type of rainfall is mostly encountered in the places that are pretty close to the equator. Example countries like Indonesia, Malaysia, and Philippines. This type of rainfall is usually very heavy and result in thunderstorms.
Aerographic rainfall. The word orography derived from a Greek word oros, which means a mountain, found on the windward sides of mountain ranges lying across the path of prevailing terrestrial winds. The leeward sides of the mountain is the rain shadow region. Orographic rainfall gives saturated air from sea, hits the mountains, air cools in high altitude, falls as rain in the mountain slope. Formation of orographic rainfall. Evaporation of water from the ocean, onshore moisture-laden winds. Mountain forces the air to rise. Air cools down. Water vapor condenses to form clouds. Further cooling leads to precipitation. Rainfall that occurs on the western Ghats, southern slopes of Himalayas, and the Great Indian Plains during the rainy season are orographic type.
This is how orographic rainfall happens. Wind from the seas contains a lot of moisture, and when it reaches a mountain, it cannot continue and is forced upwards. As the air masses goes upwards, it cools and eventually condenses into clouds. Soon after, the cloud can no longer hold any more water and it begins to rain. Most of the precipitation ends up on the side facing the ocean, called the windward side, while the other, or leeward side, gets little. This causes one side to be moist and full of vegetation while the other is dry.
Cyclonic or frontal rainfall occurs along the frontal zones of convergence, meeting of hot and cold air. Cold air push up the hot air. As altitude increases, the hot air cools down. Condensation happens. Rain occurs. Frontal or depression rainfall. Warm moisture-laden air from the south meets cold air from the north and forms the warm front. Further cooling leads to precipitation along the warm front. Winter precipitation in northern parts of India, Europe, and North America is of frontal origin. Occurs notably in the intertropical convergence zones and the polar front. Cyclonic rainfall. When a warm moist air mass meets a cold dry one, the warm one rises and the water vapor in the warm air condenses as it rises, forming clouds. It will rain. If it's a warm front, then the warm air will gradually rise, causing a mild to moderate prolonged rainfall. It is a cold front, then the warm air will rise quickly, causing unstable weather including thunderstorm. Types of rainfall. Relief rainfall, Stage 1. Warm wet air is forced to rise over highland, Stage 2. As the air rises, it cools and condenses. Clouds form and precipitation occurs, Stage 3. The drier air descends and warms, Stage 4. Any moisture in the air, for example clouds, evaporates. Convectional rainfall, Stage 1. The sun hits the ground and warm air rises, Stage 2. As the air rises, it cools and condenses to form clouds, Stage 3. Large cumulonimbus clouds are formed, Stage 4. Heavy rainstorms occur. These usually include thunder and lightning. Frontal rainfall, Stage 1. An area of warm air meets an area of cold air, Stage 2. The warm air is forced over the cold air, Stage 3. Where the air meets the warm air is cooled and water vapor condenses, Stage 4. Clouds form and precipitation occurs. Similarities and differences. All three types of rainfall involve warm moist air rising, warm air cooling, the water vapor condensing to form clouds, further cooling leading to precipitation. The difference is the reason why the air is rising. Relief or orographic. Air is forced to rise over mountains. Convectional. Air is being heated. Frontal. Warm air is rising over cold air.
Estimation of missing rainfall data. First is arithmetic mean method, second is normal ratio method, and third is double mass curve. First is the arithmetic mean method. The simplest of all is the arithmetic mean method, which takes an average of all the rainfall depths as shown in this figure. For example, we have here 4 rain gauges, and to get the average rainfall, i-add lang natin kung pira ang reading sa bawat gauges, then i-divide natin kung pira kabilog ang gauges sa problem. In this example, we have to add 5 plus 8 plus 12 plus 15, then divided by 4 because we have 4 rain gauges, which give us the answer of 10 millimeters. Next is normal ratio method. If the normal precipitations vary considerably, then Px is estimated by weighing the precipitation at various stations by the ratios of normal annual precipitation. The normal ratio method gives Px, and this is the formula on finding the Px, as you can see in the figure. This method is based selecting in M. M is usually 3 stations that are near and approximately evenly spaced around the station with the missing record. So we have here the example. The normal annual rainfall at stations A, B, and C, and D in a basin are 80.97, 67.59, 76.28, and 92.01 centimeters respectively. In the year 1975, the Station D was inoperative and the stations A, B, and C recorded annual rainfall of 91.11, 72.23, and 79.89 centimeters respectively. Estimate the rainfall at Station D in that year. So we have here the solution. As the normal rainfall values vary by more than 10%, the duration method is adopted. So let's substitute the given to the formula. So we have to find the rainfall at Station D. The normal annual rainfall at Station D is 92.01 centimeters divided by 3 since we have 3 other more stations. Then we will multiply to the recorded annual rainfall of A, which is 91.11, divided by its normal annual rainfall, which is 80.97, plus the recorded annual rainfall of B, which is 72.23, divided by its normal annual rainfall, which is 67.59, plus the recorded annual rainfall of C, which is 79.89, divided by its normal annual rainfall, which is 76.28, which give us an answer of 99.41 centimeters. That is our estimated recorded rainfall at Station D in that year.
So let's have an example of the double mass analysis. So the double mass analysis is used in testing the consistency of the rainfall data, and it is used to adjust it. So we have the recorded rainfall at stations A, F, G, and H. And then it is for the year 1979 to 1986. So we are asked to adjust or to test first the consistency of the recordings at H and to adjust the lower section. So the first step is to find the total of the adjacent stations. Total of EFG. So this is simply equal to sum of E to G. So we can drag this one here. Next is we have to find the cumulative of EFG. So this is equal to 71. The second one is equal to the previous plus the current. Okay. And then we also have to find the cumulative of H. So this is equal to 28, and this one is the previous plus the current. Okay. And we have to plot this to make a double mass curve. So this will be our x values, the cumulative of E, F, and G. And our y values will be the cumulative of H. So we can plot this. So this is our original data. So let's insert some axis titles and data labels. So okay. Okay. So notice that there is a change in slope in 1981. So this is our cumulative of H, and this is the cumulative of EFG. So we have to adjust the lower section. So it means we have to adjust the values of H for the year 1979, 1980, and 1981. So, in order to adjust the values, we have to find our correction factor. But first, we have to calculate the slope at the lower section and the slope at upper section. So, slope of, so S is for the slope of 1979 to 1981. So, this is equal to the rise over run, which is 99 minus 0 all over 229 minus 0. So, the slope of this one is 0.4323. While for the upper part, so slope of 1981 to 1986. So this is equal to 230 minus 99 all over 573 minus 229. So the slope here is equal to 0.3808. So this is one. So our correction factor will be, let's name this as the ratio. So this is equal to this one all over 0.4323. So let's name this as the adjusted H. So we have to adjust this. So this is equal to 28 times this one. Okay. So we have adjusted the values of H for the year 1979, 1980, and 1981. So, okay. So, of course, the values of H for the succeeding years will still remain the same. Okay. Let me just copy this column. Okay, so let's just let's copy this column. Control-C. Then and of course we have to adjust also the cumulative of each. For the adjusted H. So this is equal to, this one. This is equal to the previous plus the current. And let us check. Okay, so let's name this as the adjusted. data. And then let's add some axis title and some data labels. So value from cells. Okay. Check the y value. And then this is the axis title. Cumulative of adjusted H. And this is the cumulative of EFG. So now that we have adjusted the data, let's compare it to this one. So notice that now our slope is constant, unlike to this one. So this is now our new double mass curve.